a product manager, and one of the areas that I focus on is the analytics part. So which is what we call intent-based analytics. So anytime you hear the term IBA or intent-based analytics, this is what I do. So I'm going to continue here on the demo environment. So basically, you have seen how you can massively increase your design and network architecture versatility with Freeform and the wildest topologies you can deploy, like a London Tube map, which is great. But you know, what we want is we don't want to compromise on the turnkey aspect. At least, you know, not all of the turnkey capabilities that we had. And typically, what we want is to be able to still continue provide all the goodness of the analytics and the continuous validation of that we have in Apstra, along with the design flexibility that you have with Freeform. To do that, basically, I'm going to show some of the intent-based analytics capabilities, right? Basically, so if I think of in terms of validation and of my network, like as a network engineer, the first thing I want to do generally after having deployed my network is to validate my control plane, right? So so this topology heavily relies on BGP, which means naturally the first thing I want to validate is BGP. Now, when it comes to validating BGP, what do I have to do? Like the first aspect is I want to list all my BGP sessions and not miss anyone. So basically, from an inventory perspective, making sure that I have the listing of all my BGP sessions running in my network. And then I need to make sure that their state is an established state, right? Which is what I want to validate to declare that my desired state is actually matching my actual one. But then I want to make sure that that state is stable over time. And the worst thing that can happen is basically I have pushed the configuration, I have checked my show BGP run, and I see that my session is established, and then I move on. But basically, this can be flapping eventually over time. And if the session came up once, it means your configuration is correct, at least your cabling is correct. But if the session is flapping, you'll be having like gray failures issues. And you know, this is one of the the toughest one to validate. So how we do that, right? So we have among the built-in intent-based analytics probe, we have one which is called BGP session monitoring, right? So you can either go into the details of the probe itself to check what data is actually collecting and how it is actually presenting it, so waiting here for this to refresh, or actually I might just use this dashboard here. What I'm doing here is I have this dashboard that I'm calling BGP monitoring, which is listing the BGP sessions that are down in my network. So we have some delay. So what I'm doing here is to avoid alert fatigue and just display all the data. What I want to know is do I have sessions down in my network? So basically, if something is not matching my intent, and if that's the case, display the information. So with all the metadata, so source, destination, IP, ISN, and so on, and display basically the historical version of this over time. So for example, what you see here is, and we have a Chaos Monkey in the background to basically go ahead and create some issues in the network to cause those BGP sessions going down. So here I have basically roughly sessions going down every 30 seconds and different ones. And I'm displaying here on the left side the sessions that are actually down, and on the right side the historical version of this over time. So in this case, it's in the last hour, which gives me like an appreciation of how my session was behaving over time. So in this case, for example, this one is really going down a lot. And all of this, I never had to provide the list of my BGP session. Like the probe automatically discovered that. So the same way you have the config template, which leverage the data structure from the device context to find the neighbor and automatically configures that, we want to have the same simplicity on the analytics part and have automatic discovery of all those sessions. So if I go into my my probe here, I will see that I am currently monitoring 720 sessions, and that's because if I look in my topology, I do have 360 interface links actually, and basically we are monitoring both ends of every link, so it comes down to 360 twice. So and we have this capability to automatically discover all the sessions, even though they were not really part of the abstraction from the beginning, right? So we keep the same simplicity in terms of dynamic discovery of all this information. And then if I want to then display more information from a flapping perspective, I can then augment this dashboard here with other stages of my analytics probe to display like what is flapping. And what is flapping is something where I can give my own definition. So it's like my own service my own service objective, where I can say, if something is flapping more than X time over X period of time, alert me. This will basically show you like more or less a view, a similar view, but focused on something that basically is flapping. In this case, I have, and this is going dynamic with updates between the two views. What I can see here on the right side, as per my own definition of, I do tolerate, I don't know, 4 flaps every minute, and if it goes, more than that, go ahead and alert me so that basically I can get a view of how stable my network is. So this is a way to basically insert your own expectations in the analytics part. So this is an example from a control plane perspective, and we can then look at. Let's say I have my network, which is stable from a routing protocol perspective. I can then move on to more data plane oriented validation. So to do that, I'm going back into my dashboard here, and I will go ahead and look for another dashboard. So I'm going to look for something called, where is it? This one.
So one thing that's really impressive here is that you see the link tags that we used. I forgot, she asked the question about metadata, and we're using the metadata that we create to drive configuration, but we're also tying that metadata to drive validation and analytics side of the house, and it updates in real time. So you could say, here that 164 generated a med that Alessandro used for BGP, but we're also using that same capability and that same technique to drive validation. So it really is closing that loop and being able to parse in real time data that exists in the graph and operate dynamically.
So basically what I'm doing here is, so the first step in terms of traffic monitoring is I want to look at my transmit and receive interface counters, right? So here I'm basically putting the information from the network, and I'm saying, let's focus on the top 10 talkers, for example. So I want to see this bar chart race here with the top 10 interfaces in terms of transmit and receive counters, but I want to have all the metadata that comes with it. So I have my source device, source interface, my destination interface, and then the destination device. So all of this is coming from the graph context that we have seen earlier, along with the tag. So here I'm putting the link tag, which represents the latency, but if I have been tagging, for example, the nodes to represent the color, for example, which is something we could have done to basically tag the nodes as in red line or circle line or pick it, whatever, the purple line, I can then also pull this information and represent the tags here to represent the nodes tags. So and if you want to see what this actually does, so what you see here is the detail of the probe with the graph query that goes and fetches the information from the graph database, right? So this is a graph query language to go and say, give me the keys I'm interested in for this data collection. If you want to see like kind of visually the type of processing that is happening in the background, So this is taking, of course, some time to display. So what we are going to see here is the result of this graph query, because when I'm authoring my analytics probe, I'm creating the graph query, and then I'm getting the result in a JSON format. And once this refresh, I can show you this from a visual perspective. Maybe I can actually continue on the probe, but I'll come back to it later once it's updated. Anyway, so I'll just continue and then come back to this view. So this is my top 10 talkers with my transmit and receive counters, and I can do it on any counter I want. But this is more unitary data collection, right? We haven't done really analytics on it, so I can then decide to do some aggregation on this data. And so, for example, one of the metrics that matters is the total amount of traffic crossing the given switch. So my total packet per switch, packet per second traffic crossing my switch. And in this case, we're grouping the information on a per node basis. So listing here again my top 10 talkers with a huge traffic of 15 packet per second. This is a virtual demo environment, but you get the idea. So that I can have really the aggregated view on a per device basis, right? Coming back here, right? So this was my my graph query efficient. So the point being, you can basically use the graph query to leverage any information that you have been using from your device context to filter exactly on the data collection that you want, to filter the scope of the devices that you want to collect data from in the specific condition that you're interested in, where we can filter based on, for example, only whatever red lines, stations in the red lines, for example, and you can narrow this down to really specific use cases that you're looking for. Can
you talk a little bit about how you integrate this then with other solutions? Because obviously, the NOC is going to have stuff coming in from all places, and maybe there's going to be a main dashboard somewhere, et cetera. So what are the integrations you typically see to get this information in front of the people that are responsible for alerting and fixing it?
And just to tag onto that, is I have something that's very in context with that. Like if it's logic monitor and then extend that out into SLA. So I've got pager duty, and now I have engineers who are on a time spot to respond to something. Where are they going? Are they going to logic monitor? Are they coming here? Are they going back into ServiceNow where the ticket also got created? This has to work into a flow. I can't just come here, or can I?
So usually what we do is what you see here is that the data at any stage from the moment where it is collected, we call it raw data at that moment in time, and then throughout the journey of the data, throughout all the analytics pipeline, at any stage, when this is more the process data up until the moment where we eventually raise an anomaly. At any point in time, you can decide to stream out the data from Apstra towards an external data lake, right? So we use basically Google protocol buffers to stream data, to stream out the data. And we have customers basically, sending this towards the data lake. So they use, Telegraph or whatever collector like that. So they get the data already aggregated, normalized from Apstra with all the metadata that comes with it, meaning this is that device with, from this blueprint, that interface, and so on. The data is normalized across different vendors, models, and so on. And we send this to their data lake through the gRPC streaming. And from there, this goes into the backend, based on whatever stack you may be able to use.
Can you communicate with message buses, for example? You see these alerts coming up that BGP is down on particular links or nodes. Can you send a message out to the message bus to be picked up by another app?
So what we have found out for now is the technology that we have been using is more like a streaming technology, so a data streaming technology. Message bus, you're talking like a Kafka type. Yeah. That's not something that is currently implemented in terms of regular stream out capabilities. but yeah, it's more based on gRPC type of streamer that we're seeing. But yeah, I mean, it could be an option that we could also consider to send it through a Kafka bus, for example.
So there was a previous NFD. I don't know if it would have been 27, maybe. It was a year or so ago. We showed some ServiceNow integration that we had developed as a concept. So, you know, sort of a two-way interaction. If somebody makes a request, we implement a config change, we give some feedback back to ServiceNow that this happened. So that, and then all of that work is on GitHub. So, you know, that was intended to show a framework of how we would work with specifically ServiceNow, but that's a pretty flexible platform. So,
but that's a request from ServiceNow to you first. If you're receiving the alert, how do you push that out to the system to get the right people to aggregate other stuff?
It's part of that same demo as well. So that demo is set up whereby it's a bi-directional sort of workflow where apps are sending something, ServiceNow is consuming, hitting a workflow where you click on to approve, that's then triggering an API call that is doing something inside of Apstra. So it was a bi-directional workflow. In answer to your question on, you mentioned Logic Monitor, I think. So we have a customer who uses just for, to your point, what the customer said, we had a conversation with him and he said, look, I've got so much screen real estate and it's of one. I've got one screen and I've got, I've got to monitor infrastructure on one screen. And that's what they used Logic Monitor for. And they were exploring PagerDuty. And what they did is they chose, we show a lot of data. Like we can get a lot of data out of here. And for him, like BGP being up and down may not be something that he wants to send to there. But if he has EVPN down, or if he has routes down, or some critical server down, he wanted to send that. So he chooses, to Mehdi's point, in any point of that pipeline, he would choose the piece of process data that they wanted and would send that to Logic Monitor, that Logic Monitor would act on and be that aggregation source. So he was filtering information and presenting it through that single window of Logic Monitor. Okay.
Yep. All right. So continuing here, so we started by collecting counters on an individual basis, on a per interface basis, and then we aggregated that on a per system basis. And then what you can do is you can then start inserting then your expectations in the probe and say, I want to be basically alerted if the traffic, the total traffic, is going outside of let's say the normal condition, and you can give your own definition of what normal condition is. So for example, here what we have done is we defined a notion of hot as being an interface that is going over a specific traffic threshold. But we want this to be true, this condition to be true in a sustained manner. So I want to classify or characterize an interface as being hot if it is above whatever number of packets per second in a sustained manner for the last, 2 minutes or 5 minutes, for example, which is basically a first level of alarm condition. And then I want to be alerted only if there is a certain proportion of interfaces on a given switch which are hot. And we have set the threshold, for example, to 30%. So if I exceed more than a third of my interfaces in a given switch, where those interfaces are above a given threshold for a given duration of time, then I classify this device as being hot, and I want to be alerted. And then in terms of data visualization, we can have different options. So this is a fuel gauge, but the point is really to focus as much as possible on the insight, so that you don't have really to go into the details of all the data collection. You can, if you want, to go into the probe, but the goal here is really to present the user with high-level dashboard that fits his own expectation based on the logic that he has provided into the probe. And this is where basically we can see here that I have, again, a number of devices where I have set a threshold at 30% of interfaces being hot, and a number of them are around 50%, some of them are 100%. And again, this is a simulation network, so the threshold is relatively low, but you can have a hot and a cold one, so you can then use this in your capacity planning and so on. So these were just examples of like a control plane type of validation and more a data plane one. We're adding a number of probes which are available to freeform. So we're going to have environmental ones to check power supplies, fan temperatures. We're going to have optical transceivers one that monitor the transmit and receive power levels and all the optical transceiver metrics. Of course, CPU, RAM, consumption, and so on. So all the physical, environmental, all of that is available out of the box. And we're going to add as much as possible, even logical ones. Just like BGP and other ones, so that you can still have this turnkey experience on the continuous validation and continue to leverage the cool, I would say, aspect of turnkey and still combine this with the flexibility of the device configuration, right? Because this part is really probably one of the hardest part in infrastructure automation to go into the data collection, data gathering, data storage over time, creating time series database, doing the analytics and so on. So we don't want to have a do-it-yourself experience. We want to still continue having a turnkey experience there, combined with the do-it-yourself more on the configuration part. And I think, yeah, that's all for me. And pass it over to.
Are these dashboards, the little applets or whatever, they're part of the dashboard, are they consumable via API as well?
Yeah.
From outside? Okay, because I'm thinking of, one of the problems in IT is we all have monitoring systems, and this group has their monitoring solution, this group has their monitoring. You maybe have a big one for the NOC. And so every time you add another monitoring solution, it's just one more place you've got to go look at stuff. So if you've got APIs for this stuff where you can easily pull it into your main solution, that would be great. Yeah, it's API first, of course. Yeah, it's API first. So basically, you have ability to access this via APIs. In addition to basically streaming the raw data if you want to then process it, and then you can have, of course, rollback access to have customized views on a per operator basis, and some dashboards are more relevant to some more populations compared to others. So you can have different dashboards and different users mapped to those dashboards based on the content that is actually showing. Any other question?
I want to ask the obvious questions. How do you keep from nuking everything systematically?
What do you mean?
Like if you push configs out, I'm looking over here.
I didn't get it. Go ahead.
So I think it's I'll quote Spider-Man: "With great power comes great responsibility."
Yeah.
So I think what you're saying is that in Alessandro's example, I can totally destroy 310 things with a push of a button. And I may or may not have had to drive 2.5 hours because I put an access list in the wrong order on a Cisco device. But so there's a few, I would say, safety mechanisms in place. One is that nothing is ever committed. It stages in uncommitted so that you can review it and you can see diffs, contextual diffs.
Like I don't just go next, finish.
We do have a little stop. Yeah, we do.
I clicked OK anyway.
It's exactly what I told him to do.
Yeah, exactly. Yeah, so we did try to. That's why we do that little banner pop up.
See things other than the config. Does it do any kind of contextual checking that hey, this BGP is not going to come up because your config is like wrong, or is it just a config? You have to look at it and know that.
It depends. So you're touching on something very important. So the answer to that is it depends. So, and I'll compare and contrast actually the data center reference designs, which we've had from the beginning, between freeform. And so, yes, there is context that will say this session will down or this link will go down. But in the data center reference design where we model everything in the semantics. So when Alessandro did a drain, he was the author of what that semantics was and what that drain meant. In the data center reference design, we handled all of that for you. And we know what BGP pairs happen. We know how to, drain that off in a very reliable multi-vendor interoperable way. And so we handle all of that. So in that case, because it's a much more modeled and highly abstracted and model-driven interface, we can say, I know for sure that this neighbor is going to be impacted. And we can tell you that.
Yeah,
beforehand.
that would be the key there. It's you need that big red flag that says that, by the way,
Don't hit.
You know you're
can
about to
hit
take
next.
this down.
but you're going to bring down 30 devices in
Yeah.
the process.
Yeah,
Because-
exactly. And in context of
If-
freeform,
If you just show me a config, I'm perfectly capable of typing out, not necessarily in something like Notepad, but say in Notepad, a config, looking at it and going, oh, that looks perfectly right, doing a copy and paste and still killing the thing because I forgot a keyword.
Or the ASN was one number off.
But you're talking about, things that you do, but things like you shut down that router over there, but it's running BGP and that affects those routers over
Yeah.
there. Now I can't get to those routers.
Yeah.
yeah.
Yeah, so in the very, very opinionated reference design, when we understand what the design is going to be before it goes, and we've got all of these checks, those red flags are really bright.
Yeah.
In freeform, when we're letting you do whatever you want, we're giving you a really
You're
powerful
letting me
tool.
do whatever I want.
Yeah.
And there's a limit to the checks that we can do because we don't know in advance what your intent is until you do it. So there are trade-offs between those two models. In each of these, you've got a huge fallback, and that's rollback. Oops, I clicked check.
the device
I
is
went a
reachable
little
after
too
my
fast.
change.
That's
So-
I need to undo. We
Well,
have a
so
big
because,
undo button.
that's such a good point. So even if the device goes offline, we're communicating with the out-of-band network.
Yeah.
So
If there's an out of
there's an
band,
out-of-band-
you're talking about a metro network spread across the entire city or half a state.
Yeah.
That's not necessarily.
I'm sure there's some corner case that we could all paint, that we could all kill ourselves.
I
but-
was gonna say, how many data centers have you been in where you look at all the back and you see the management ports and they're all empty?
Yeah, I mean, sometimes your management network is a VLAN that goes over the same wire as everything else.
Yeah.
There is no out of band
That's-
network, but
Yeah, there's certainly, I mean, we could all paint in number of
Yeah.
corner cases where we
Sure,
could
sure, sure.
to do
a
it.
corner.
But there are checks to make sure you don't lose connectivity to that device. Because I mean, you could in the config push out, shut down that management interface.
What
right?
if you wanted to shut it down?
So that's
Agree.
I love this
Being a-
discussion, yeah, because this is the whole trade-off, right? Like when we said we want to cover it all, you can go from being from this discussion. I think you guys need the turnkey solution, and that's ultimately why we came up with intent-based networking. The idea is we want to give you the most reliable experience, and that's when we model everything, and ultimately we guarantee everything is going to work. The more freedom we give in terms of how versatile we want the use cases to be, the configurations to be, that becomes a sharper knife, and with power comes responsibility. The good news is that you can really use the product in whichever way you want. You can be as versatile as you'd like, or you can take it all the way and model every aspect with the turnkey solution.
Everything that we've shown here is resources for those of you watching this live stream and et cetera. There's video demos with walkthroughs and et cetera, but I'll call your attention. We have Try It, the Cloud Labs, which is a sandbox, multi-vendor sandbox that has pre-built network topology, student guides that you can walk through. You can see what this product actually looks like in both data center reference design or freeform. We have everything that Alessandro showed today, plus more. There he is, Alessandro. Everything that he showed today, the JSON files, et cetera, are in this GitHub repo for you to look at, evaluate, check out how Jinja works, and et cetera, and some education.